All right, this is problem number 16. We're going to try to get to 20. Problem number 16 asks which explicit formula describes the pattern that we're seeing in this table, D and C. Now, they have on the options, the variable D and the variable C are sort of flipped around, but that's okay. Here's what you can do. Just take a look at one option at a time, okay? And look to see if you plug, and I would rather plug that number in, do you get the C, the 6.28? So plug in, and do you get? Okay? And then if you have more than one that the answer is yes to, then you'll move down to 3 and 9.42. 9.42. So, looking at option A, and I'm just going to try option A first. D, which I'm saying is 2, is equal to 3.14 times C. I don't like to use the X for times, so I'm just going to set them beside each other because it means the same thing. If you divide both sides by 3.14 in order to figure out what C would be, so there's a very small equation you'll have to solve here. C is going to equal to 2 divided by 3.14. Well, I mean, you can put that in your calculator, but you know that if you take 2 and you divide it into 3 pieces, it's going to be a lot less than 6.28. It's going to be like 0.6 something, okay? So, so basically, A is not it, okay? Now then look at B. B says 3.14 times C is equal to D, which I said, well, we're going to put 2 in. This is essentially the same problem as A. You end up having to divide by 3.14, and you have C is equal to 2 over 3.14, which is approximately equal to, same thing, 0.6, which means B is not the answer either. Okay, so we've said no to A, we've said no to B. Let's move on to C. C, 31.4 times 10 is equal to C. There is no D here. 31.4 is times 10 is 314 is equal to C. That means that it doesn't matter what D is, because D is not in the equation, then C should be 31.4 or 314, excuse me, and it's not. You can see that C does vary, and C does depend on whatever D is. So C is not the answer. Well, process of elimination tells you that probably then D is, but I kind of like to check it just to make sure. So C is equal to 3.14 times D, which we're calling 2. And 3.14 times 2 is 6.28, which does match right there. When you plug 2 in, you get 6.28, so the answer is D. Okay, next problem, number 17, which table represents an exponential function? Basically, always subtract first. So this one, 5 to 6, it went up 1. 6 to 7 went up 1. 7 to 8 went up 1. 8 to 9 went up 1. That means that this has a slope of 1. If it's addition, then it's linear. Okay? Constant first difference means linear. From 0 to 22, it went up 22. From 22 to 44, it went up 22. 44 to 66, it went up 22. And 60, put too many 2's there. And 66 to 88, it went up to 22 as well. Okay? So basically, here, if the constant first difference is 22, that means the slope is 22, and it does mean that it's linear. Here, 5 to 13, it went up 7. 13 to 21 went up 7. 21 to 29 went up 7. 29 to 37 went up, let's see, 29 to 37 went up, oh, back up, sorry. Somebody can't subtract. Here we go. 5 to 13 is not 7. That's 8. 13 to 21, that's going up 8. Now she's got it. Up 8 and up 8. A constant first difference of 8 means the slope would be 8 and that it's linear. Okay? Now, I'm going to tell you that D, obviously, just by elimination, A, B, and C can't be it because they're linear, and linears are not exponential. They're different things. D is definitely the answer. However, this is wrong. That should be 1 right there. It doesn't work unless it's 1, okay? And so now let's look. From 1 to 3, it goes up 2. From 3 to 9, and you'll notice I'm still adding because I want to see the first differences. That's going to be important to me. From 9 to 27, I went up let's see, up 2, up 6, up 18. And then from 27 to 81, and you know, this is when I would get my calculator out, I went up 54. The reason I wanted to see that is I want to see what did I multiply by. And here, I multiplied by 3. Here, by 3. And here, by 3. Okay? If you do a first difference, it's easier to see what the common multiplier is, and it's 3. That means the repeated multiplier is 3. Okay? Now, all you have to do to figure out, I'm going to do it this way because I just like it better. I always put n minus 1 right there, okay? But to do that, you have to start at 1, and then you put the initial multiplier there, okay? So if you were to write this equation, it would be 3 to the first times 3 to the n minus 1, which is equal to 3 to the 1 plus n minus 1, because remember that you add exponents, and 1 minus 1 makes it 3 to the n. So it actually was just 3 to the n, but that little part right there was incorrect. So do remember that if it's exponential and it doesn't have a multiplier on the outside, that it has to be 1 right there, because anything to the 0 power is 1, so that's a mistake. Looking at number 18, a regular pentagon is centered about the origin and has a vertex at 0, 4. Which transformation maps the pentagon onto itself? Well, firstly, if you're going to flip this thing around, well, let's just go through it. A reflection across the line y equals m. If you were to reflect this across y equals m, and this is how I figure this out, we're going to look at A first. Reflect that, it would be, that's 1, 2, 3 units to the bottom, right there. Those would be on there, the two corners. Okay, and it would be something like that. Basically, it's asking when it says reflect, what maps it to itself, is the pink one laying down right on top of the black one? Would you end up with the same figure? And no, if you flipped it across the line y equals m, it would be upside down. Okay, a reflection over the x-axis. Okay, so it's another horizontal. If you reflected it here, okay, it's still going to be upside down. It's going to look something like that. So no to A, no to B. All right. All right. A clockwise rotation of 100 and of 144. Here's what you need to know. This is the important part. Okay. If you start here and flip something all the way around, that's 360 degrees. Okay. It will only map to itself 5 times within the 360 because it's a 5-sided figure. So 5 into 360 would be 72 degrees, okay? Now you'll notice I don't see a 72 degree, but remember, it happens at multiples of 72. So that means that it will fit back into itself at 72. Also at 72 plus 72, which is 144. Also at 72 plus 144, which is 6, 11, 216, and so on. I'm going to stop there, though, because I already found one of my answers, 144. So keep in mind that it doesn't have to go just once. Do 360 divided by the number of sides, but then start adding that degree measure back to itself, because that's 72 degrees, that's 144 degrees, and so on. That's counterclockwise. Hold on. I'm going the wrong way. It would be going this direction. So this point would fit back into this point at 72 degrees, okay? But this point would fit into that point at 144 degrees. So it keeps fitting into itself over and over, and that's what it means to map back onto itself. Number 19, if you've got those vertices, which one maps it to itself? So again, you're looking for the thing that will sit down right on top of itself, okay? So a reflection across the line x equals 2. Well, if you reflected this every point, and you can see there's a point, there's a point, there's a point, and there's a point. If you reflected them across, basically, the new point right here, right there, this one is 2 from the left, so you would go 2 to the right, and this was 2 from the right, so you would go 2 to the left. This is a reflection about the line x equals 2. So A is not the answer, okay? Going back. A reflection across the line y equals 2. So looking at y equals 2, that's this line right there. this point right here is 2 above, and so you would put it 2 below. That's what reflects it. This point right here is 1, 2, 3, 4 above, so you would have to go on that same plane 2, 4 down. Okay? I'll put that prime, and let me make this prime. You have to mark it in some way so you can see what the new ones are. Okay, this pink, if you reflected it around y equals 2, it would come over here. No, whoa, 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 whoa. Wrong. If you reflected it, there's my prime. If you reflected the pink point around y equals 2, you'll see the pink point is 2 below, which means your prime point would be above. And I'm going to mark it with a little prime. Okay, and lastly, a red point right here on the corner. It is 2, 4 below the line y equals 2, which means its prime point would be 2, 4 above. Okay, now if you connect those, the question it's asking is, does the new figure fit back into the old figure? And the answer is no, it does not. So B is not the answer. Okay, it wants to know if you rotate around 2, 2, 180 degrees. Okay, so if you take this point right here, 6, okay, and you go 180 degrees around here, notice that if I have the center, and let me put a star at the point 2, 2, okay, to get to that blue point, I would have to go up 1, 2, 3, 4, up 4, and I would have to go left 1, 2. Okay, which means that you would do exactly the opposite to get to its prime point. So down 4 and right 2. So down 1, 2, 3, 4, right 1, 2. There's a prime point. Now this is a possibility because you'll notice that a prime point is on the actual axis. Okay, so now let's do that point. Okay, to get from the starred center, the point 2, 2, to that red point, I would have to go up 2, 4, no, up 1, 2, and over 1, 2. So up 2 and to the right 2, which means the prime point would be down 2 and left 2. So if I start back at the start and go down 2 and left 2, there's my prime point, which is also on a vertex, so this is a pretty good sign. Okay. Now then, if I went to, and basically, if the prime point is 180 from the original point, then vice versa would happen too. So I really don't have to check the other two. The answer is C. Okay, if you want to do, but just remember that the center is where you start. Just count how you got there and do exactly the opposite of everything you just did. Last one, which transformation maps triangle ABC to RST? Okay, so keep in mind when they say this, it wants A, which I'm going to make that be green, end up at R. The order definitely matters, okay? It wants B to end up where S is. And it's asking you to figure out a way to make C end up where T is. And that is extremely, extremely important, okay? The first one, it says reflect across the line x equals, let's just go ahead and add a line here. If you are reflecting this across the line x equals -1, x is up and down, okay, and let me just kind of move it over a little bit. Alright, alright, there's the line you're reflecting over, okay. Reflecting it over, you just count distances, that's all you would do. So the pink dot is 3 to the left, so 2 to the left of the orange line, so you would go 2 to the right of the orange line. Okay, the blue dot is to the orange line, 2 to the left, so you would go 2 to the right. Okay, and the green dot is 4 to the left, so you would go 4 to the right. 1, 2, 3. Wait, did I count that right? Hold on. 1, 2, 3, 4. 1, 2, 3, 4. Yes, I did. Okay, that's your first stop. Okay. Okay, so that one would maybe. Then translate 1 unit down? No, it's down a lot more. To get from pink to pink, you'd have to go down 2, 4, 5. So reflect around y equals 1, then translate 5. There it is. The answer is B. Okay, so that was 16 through 20 videos. Good luck studying. Check with your teachers at your school if you have any questions.